Welcome everyone. In this video, we're going to discuss how a function changes if we move in the direction of a vector. So the idea is to estimate how much the value of a function f changes if we move a small distance ds from a point PO in a particular direction. So somewhere nearby PO, so not too far away. So if you remember in single variable calculus, you can do it this way. The change in f, it's going to be the derivative of f evaluated at the point PO times that little change. So we use this formula for single variable function. Now, if you have multivariable, for example, 2 or 3 or more, then we're going to be looking at this formula right here. So instead of looking at derivative at a point, we're going to be using the directional derivative. So the formula pretty much tells us that if you want to determine the change in f, we find the directional derivative in that direction of a vector u. U will be a unit vector, and we multiply that by that little change, ds. So that's the distance increment. So keep in mind that this vector u is going to be a unit vector. So once you find that vector, the direction we're changing, we're going to turn that vector into a unit vector. So let's see how this is used in a quick example. So here's the example we're going to be working on. So we want to know by how much will this function, this is a function of 3 variable, change if the point xyz moves from PO, which is this point right here, a distance of 0.1 unit in the direction of this vector. So that means we need a unit vector in that direction. So first thing we're going to do is compute our unit vector u. So u, it's going to be this vector. Let's call this vector v. So that's going to be the vector b divided by its magnitude. So this is going to give us the following. So you'll have your components for vector v are 3, 6, -2. And we're going to divide that by its magnitude. So that'll be square root of 3 squared, that'll be 9, plus 6 squared, that's 36, plus 2 squared, that's 4. So once we do that, we get our unit vector. So the denominator will simplify to a square root of 49, which will be 7. And then we multiply this by our component of vector v. So that's 3, 6, and -2. All right, so we found our unit vector. And now we're going to hold on to this answer. Now we're going to compute the gradient of f, and we'll evaluate that at PO. So the next thing you want to do is compute the gradient of this function f, and that's going to be the partial of f respect to x, y, and z. So let's go ahead and compute that. Now, before we compute, I'm going to rewrite this function so that differentiating becomes easier. You can also write this by using laws of exponents. This is 1/2 ln of x squared plus y squared plus z squared. So a little bit of rewriting helps you evaluate easily, and taking partial derivatives is also easier. So now we're going to use the chain rule from calculus 1 to find the partial derivatives. So our partial derivative respect to x of this function is going to be 1/2 times 1 over the derivative of ln of x squared plus y squared plus z squared. So that would be x squared plus y squared plus z squared. Now, since you're taking partial derivative respect to x of this, everything is constant except for x. So that's going to be multiplied by 2. So I'm just going to put times 2 on the numerator, just like this. And then for the second term, partial of f respect to y, it's going to be very similar, except that you're going to multiply by derivative of this guy, 2y, and we can simplify it. So partial of f respect to y, it's going to be y over x squared plus y squared plus z squared. And similarly, partial of f respect to z would be z over x squared plus y squared plus z squared. So this is our gradient of this function. I'm going to go ahead and simplify the x component too, since these two will cancel out. So it's really just that. So once we have finished computing the partial derivatives with respect to each variables, we're going to go ahead and substitute our point PO. So we'll evaluate the gradient at PO. So PO is right here. So we'll plug in x is 4, x is 3, y is 4, and z is 12. So we will have our gradient to be 3 over x squared, so that'll be 9, plus 4 squared, that's 16, plus 12, because that's 144. And this will sum up to 169. So that's what I'm going to just put right here. And they all have same denominator. So we'll have y over 1 over 16, 169. So that's 4 over 169. And for z, we have 12 over 169. All right, so we got the gradient vector. Now we're ready to figure out what our change in this function is. So the change in f, it's going to be the gradient of f evaluated at PO dotted with the unit vector u. And we're going to multiply by that little change ds. So now let's substitute what we got here. So we're going to go ahead and substitute our gradient vector at PO. So that is going to be this piece right here. So we know this is going to be 3 over 169, 4 over 169, and 12 over 169. And we're going to dot that with our unit vector. So our unit vector is right here. So this is the unit vector we got. So it's 1 over 7. Now 1 over 7 is just a constant. I can just put it up front. Then we have 3, comma, 6, comma, -2. And whatever we get here, we're going to multiply by a ds. ds was given in the problem right here. This is going to be 0.1. So this is going to be times 0.1. That's pretty much how you set it up. Now let's calculate this. So we have 1 over 7 times. So now we do the dot product. So we do this component times that. We add them up. So that would be, now I can also take out 1 over 169 from each term, since that's what I have in common right here. Just a little bit of simplification. So we will get, so I guess we can put it like this, 7 times 1 over 169. And then, so we do 3 times 3, that will be 9, plus 4 times 6. So now we can multiply these guys right here. So that's going to be 24. And then 12 times -2, that's -24 times 0.1. And then, of course, this will simplify further. So these guys will cancel out. So this will leave us with, and 7 times 169, that's going to give us 1183. Okay. And then we have 9 times 0.1. 0.1, I can write that as 1 over 10. So all of this simplifies to 9 over 11,830. So that's our change in f as we move 0.1 from PO. And this is approximately 0.0008. So you can put that in a calculator and get an actual decimal. Alrighty, I hope this helped. Take care.